Hello everyone and welcome back to my channel. Today we are going to design and simulate a smart battery controller in MATLAB environment. In this project we will see how two lithium-ion batteries can be managed efficiently based on their state of charge. Here is the scenarios. We have battery 1 which is a 12 volt 10 ampere hour lithium-ion battery starting at 95% SOC. It is connected to a 1000 ohm load and is supplying power to it. But here is the twist. Once battery 1's SOC drops below 90%, our controller will automatically switch over and use battery 2, which specification is 16 volt 15 ampere hour lithium ion battery, as well as the charging is means initial SOC is 100% to charge the battery 1. We will go step by step through the MATLAB model, look at how the SOC is monitored in real time, and see the switching and charging happened automatically. So if you are interested in battery management systems, electric vehicle technology or smart energy solutions, make sure you watch till the end. And don't forget to like, share and subscribe for more MATLAB projects. Let's get started. So first I am taking power GUI. So then I am taking battery. Then I am taking series RLC branch because I have to make resistance. Next I am taking switching. So here I am using the breaker. So here you can see this is here I am using this breaker only. Okay. So this is the basic component. Okay. So power GUI I am taking as a discrete and its sampling time I consider as 1 second. Okay. And here I already set the timing. So I am consider this battery as a battery 1 and I am just input the specification of the battery 1. Here you can see already written that nominal voltage is 12 volt, capacity is the 10 ampere hour and the initial SOC is 95%. Okay, and here you can see all the calculation is already done, so I am applying. Now I have to take the output from the battery 1. So for that we are using the bus selector. I already told you in previous two videos. So just I am rotating this one. So as you know, we can get the three battery signal. One is the voltage, current as well as the SOC. So I am selecting SOC, then current and then voltage. Okay, so I am applying this. Now I take scope to see the output. Okay, so as this is the three output, so we need the three input of the scope. So I am choosing 3 and I taking the layout just like this. Okay, and just rotating this one. So first one is the SOC, second one is the current and third one is the voltage. Okay, so first case is the battery is directly connected to the 1000 ohm resistance. So I converted this series RLC branch as a resistance and its value is 1000 ohm. Okay, so now RLC is I am connecting through switch. So here you can see this is the breaker. So here I am connecting positive through the breaker through positive as well as the breaker through positive, negative to negative of the load. Okay, so first condition is completed. Now we have one more battery, that is the battery 2. Just I am copying this portion, Control C and Control V. Okay, I am rotating this portion. So now we have to rotate the battery. Control R, and here you can see I have to flip this block up down. Okay, so this is the battery 2. Now I have to put the specifications. So here you can see I already chosen the lithium ion battery, and in case of the battery 2, the nominal voltage is 16 volt, rated capacity is 15 ampere hour, and the initial SOC is 100%. I am applying this one. Okay, now the second battery portion is completed. I am just rearranging this one. Okay, now I am connecting this. So what happened, when the battery 2 is charged the battery 1, so power is flow from battery 2 to battery 1. So based on that we have to connect the breaker. So I have to change the breaker positions, and I am taking the up down. Okay, so here you can see the power is flowing from battery 1 to series 1000 ohm load. So that's why here you can see it is coming from 1, and then it is, and the output is coming from the 2, and it is directly connected to the resistance. But in case of the battery 2, so here you can see the battery 2 will charge the battery 1. So power is flowing from battery 2 to battery 1. So that's why we have to connect the breaker, that 1 to 2. So you have to remember this point very carefully. Otherwise you can get the error message. Okay, so similarly I am connecting the negative to the negative one, and here you can see this is the 3 signal, positive, negative, as well as the SOC current as well as the voltage. Now I am adding one more display to see the variations of the SOC. Okay, so I'm just connecting here and also here. Okay, so basic block diagram is completed. Now we have to make some program or switching operation. For that I am taking MATLAB function block. So just search it out, MATLAB function, you can get this one. Okay, MATLAB function. Okay, this is MATLAB function block. Okay, in this block we have to write some switching operation algorithm. So based on that, this breaker, 4 breaker will work. So input will be the SOC, because here you can see the condition is based on the SOC. When the SOC is less than 90%, then only the battery 2 is used to charge the battery 1. So I have to take the SOC. So for that I am using the go to as well as the from block. So I am using the go to block. So just search it out in the library go to. So here you can see this is the go to. So here I am using the SOC tag, SOC. Okay, I am using the capital. You can also directly connect it to this block, but I am using go to and from. So this is the from block. Okay, you can generate by directly drag this one. Okay, you can also generate go to from drag by using this one. Otherwise you can directly pick it. You can directly go to the library, and from there you can easily add the block here. Okay, so I have to write the code. So here we are taking the functions as a two function. One is the when the load is connected, and second one is the when they are be charging. So I am taking load on and charging on, and the function will be the SOC, because based on that SOC we have to decide whether it will be the supply the battery power to the load, or the battery 2 will be the charge the battery 1. Okay, so you have to write the code based on that. Then I am taking load on equal to 1 and charging on equal to 0. Okay, now the condition will start. If what happened, first condition, if SOC greater than equal to 95%, then what happened, load on equal to 1, that time load will be on and charging on will be 0, means charging will be the off, and this situation is end. Now second case, if SOC is less than 90%, then what happened, load on equal to 0 and charging on equal to 1, and end. Very simple code. Okay, just so take the save option, so it's already saved. Now I am going to the Simulink model. So here you can see SOC is the output, and we get the SOC is the input, and corresponding that we are getting two output. One is the load on and second one is the charging on. Now we are using the from and go to block. Okay, so here I am using the go to block. So we consider this as a load on, and this is charging on. Okay, so load on means the battery 1 is directly connected to this resistance, 1000 ohm resistance, and charging on means the battery 2 is connected to the battery 1. So we get that two signals. Okay, now load on means we just connected this load on signal to this switch. Here you can see. So when the battery 1 is directly connected to the load resistance, then it is activated, that is the load on. When the battery 2 is directly charged to the battery 1, that time what happens, the charging is connected. So here I am using from block. Okay, and I am connecting this to the this breaker 2 as well as the breaker 3. Okay, now everything is ready, and here I already consider this runtime. Now just click on it to run this program. So it takes very less time. You can also try it by using the continuous function. Here I am using the discrete 1 second, but you can also take the continuous function. So here you can see here the battery 2 is charged the battery 1, you can see. So that's why its SOC is decreased and its SOC is increased. Now I am directly go to this scope So here you can see. So initially the battery 2 voltage is 100. Then whenever this time what happen, the battery 2 is start charging the battery 1. So what happen, its charge is continuously decreasing. Okay. Similarly, based on that volt, you can also see the voltage profile. So here you can see voltage is above 18.5 volt, and here you can see it is decreasing. Now coming to the battery 1. So here you can see, as the condition already given, so its initial state of charge is 95% and it started decreasing up to 90. Whenever its SOC is 90, what happened, the battery 2 is start charging the battery 1. So here you can see it's charged and continuously discharged, and charge and continuously discharge. Similarly, you can also see the current profile, as well as the, you can see the battery 1 profile, and this is the battery 2 profile. So here you can see in the battery 1, it is initially directly connected to the 1000 ohm load, so it is discharged. Here you can see this is the ideal battery 2, and its voltage is its SOC is 100%. Whenever the battery 1 voltage is near about to 90%, SOC is 90%, what happened, the battery 2 is start charging. So here you can see its SOC is decreasing. Similarly, what happened, its SOC is increasing. Okay, thank you.